Hey everyone, and welcome. Today, we're going to break down one of the most useful tools in all of algebra, graphing linear inequalities. We're going to see how these go from just, rules on a page to a real-life map for making decisions.
Think about it. We all deal with limits, right? A limit on your money, a limit on your time. You're always making choices inside these kinds of boundaries. Well, it turns out there's a way to actually see all of your possible choices at once, and that is exactly what we're going to get into today. So this is the fancy math way of talking about those limits. An equation is like a perfectly balanced scale. But an inequality? That's when one side is a little heavier. It's not exactly equal, but it's less than or greater than some amount.
All right, let's start with the absolute basics and really wrap our heads around what makes this so different from a simple equation you might be used to. And this right here is the number one key difference. A linear equation, that gives you one single perfect line of answers. But an inequality, that gives you an entire region, a whole zone of possibilities. It's not just a single path, it's a whole territory of correct answers.
Okay, so before we can map out that entire territory, let's start small. Let's learn the very first and simplest step, how to check if just one single point, one possibility, is even a real solution.
And honestly, it's a super simple three-step process. You just take your coordinates and plug them in. You do the math to simplify it. And then you just ask yourself, is the final statement true? Is 5 actually less than 10? If it is, then yep, that point is a solution.
So let's try one out. For example A, we pop in -1 for x and 9 for y. We get 2 times -1 plus 9, which is 7. So the inequality becomes 7 less than -3. Is that true? Is 7 less than -3? Nope, not at all. So that point, -1, 9, is not in our solution zone.
Okay, let's dive into this next one. We're testing the point 2, -2 with the rule x minus 3y greater than 8. So we substitute the numbers, and what we end up with is 8 greater than or equal to 8. So, is 8 greater than or equal to 8? Well, yeah, it's equal to 8, and that or equal to part is key. It fits the rule. So this point gets a big check mark, it's a solution.
So now we know how to check one point at a time. But how do we find all of them without testing forever? We create a map, a visual map of every single possible solution. And that is where graphing comes in.
And just like checking a point, graphing follows a really simple three-step plan. First, you draw the boundary line. Second, you send in a little scout, a single test point, to see which side of the line is the solution side. And third, you just shade in that entire side to make your map.
Now that boundary line is kind of like a fence, and there are two types. If your inequality is just less than or greater than, it's a dashed fence. This means you can get right up close, but you can't actually be on the fence. But if it's less than or equal to or greater than or equal to, it's a solid fence. That means the points right on the fence are included. They're part of the solution.
And here's the big idea. That line, our fence, it splits the entire infinite map into two separate territories, two half-planes. Our whole job is just to figure out which of those two territories is the one with all our answers. Let's actually build one together. We've got -x plus 2y greater than 2. Step 1, we just pretend for a second it's an equation, and we graph that line. And because our symbol is just greater than, no equal to part, we draw our fence as a dashed line. All right, now for step 2, we need our scout. We have to pick a test point to see which side of the fence is the right one. And you know what? As long as the line doesn't go right through the middle, the origin, 0, 0, is always the easiest one to use.
Okay, so we plug in 0, 0, and what happens? We get 0 greater than 2? Is that true? No way! 0 is not greater than 2, so our scout failed. That means the territory it's in is the wrong one. So we do the logical thing, we shade the other side, the half-plane that doesn't have our test point in it. And that whole shaded area, that's our solution map.
Okay, awesome. We've got the technical skills down. Now let's see how this actually helps us with something real. Because this whole mapping thing, it isn't just for math class. It's for making actual decisions.
So here's our situation. You want to make a fruit salad, and you have, at most, $10. Grapes are $2.50 a pound, apples are $1 a pound. The big question is, what are all the different combinations of grapes and apples you can actually afford?
So we translate this into math. We'll let x be the pounds of grapes and y be the pounds of apples. So the cost of the grapes, that's 2.50 times x, plus the cost of the apples, 1 times y, has to be at most $10. And at most just means less than or equal to. And there we have it, our real-world inequality.
So we graphed that inequality and ta-da! Here it is. It's a solid line because, yeah, you can spend exactly $10. And we shaded everything below it. Every single point in this blue zone is a combination of grapes and apples that you can afford. This is your personal fruit salad shopping map.
Let's just pick a couple points to see what this map is telling us. See the point 1,6? That means 1 pound of grapes and 6 pounds of apples. It's deep in the blue zone, so yeah, you can afford that. Now how about 2,5? That point is right on the line, our solid fence. That's a solution too. It means you can buy 2 pounds of grapes and 5 pounds of apples, and you'll spend exactly $10. Perfect.
So now you have this amazing tool. And it's not just about fruit, right? You can make a map for any situation that has 2 variables and some kind of limit. I mean, think about it. How you balance your study time versus your fun time. How much you spend on coffee versus lunch. What choices in your life could you actually visualize with a map just like this one?